Electric current. An electric current is the flow of electrical charges through materials. When more electrical charges circulate, the electric current is stronger and more electricity flows. Electricity carried in an electric current can easily be transformed into other forms of energy. Conductors and insulators. Materials can be classified into two types, depending on how easily electrical charges can flow through them. Conductors. These are materials that allow electrical charges to move freely. For this reason, electric current flows easily through them. Copper, silver, and other metals are good conductors. Insulators. These are materials that do not allow electrical charges to move. Therefore, electric current does not flow through them. Glass, plastic, and most non-metal materials are good insulators. Air is also an insulator. Safety around water. Water is also a conductor of electricity. People are made up mainly of water, so we are conductors of electricity as well. For this reason, it can be very dangerous to use electrical appliances near water. When you are going to use an electrical appliance, make sure that you, the appliance, and your work area are all dry. Then on the right of the page here, you've got some pictures of electric wires, electric cables, and it says, an electrical cable consists of copper wire wrapped in a plastic covering. The copper is there because it's a very good conductor, and the plastic covering is an insulator, so it protects us from the electricity. When electric current flows through conductors, it can produce heat. When electric current flows through a conductor, it can heat up. This is what happens in an iron, a heater, or a toaster. Light. Electric current can produce light, like in light bulbs or TV screens. Sound. Electric current can be transformed into sound, like in loudspeakers on a stereo or a computer. Magnetism. When electric current flows through a piece of magnetic metal such as iron, it creates a magnet known as an electromagnet. Movement. In electric motors, electric current produces a turning movement, like in fans, juices, or drills. Chemical effects. Electric current can cause chemical changes in substances, like in batteries. In our classroom, there are things that use electricity to make other types of energy. For example, here in the computer, electricity is turned into light energy, also into heat energy because the computer heats up, and inside there is also a fan, which means there would be mechanical energy as well. What else do we have that uses electricity in our classroom? We also have the lights. Now lights, remember, convert electrical energy into light energy and into heat energy. We also have the projector, which does the same as the lights. It converts electrical energy into light and also heat because it heats up. Behind that, we've also got the air conditioning unit, which converts electricity into either heat or into cold air as well. There will also be mechanical energy in there because there are fans that turn around. This is a clock. A clock uses a battery. A battery converts chemical energy into electrical energy, so electricity, which makes the hands turn, which is mechanical energy. An electric circuit is a closed path through which electricity flows. The circuit needs to form a complete circle in order to work. We use circuit diagrams to illustrate circuits. Now, components of electric circuits. The basic components of a circuit are the generator. This provides the electricity, for example, a battery. The electrical charges leave the generator through one terminal and enter it again through the other. The switch. This controls the flow of electricity by closing or opening the circuit. Cables. These transport the electricity from the generator to the other components of the circuit. Cables are connecting wires, usually made of copper, wrapped in plastic covering. Devices. These transform the electricity into another type of energy, such as light or kinetic energy. Some examples are light bulbs and motors. Now all of these are examples of circuit diagrams. Now you've got the picture of the cable, then the cable is represented by lines. You've got the switch, which is represented by a line with some dots and a little open part, like a little door. You've got the light bulb, which is represented here by a cross within a circle, and a battery, which is represented by the positive and negative symbols. And as it says, symbols can be used to draw electric components. And here you've got an open circuit diagram because the switch is off at the moment, and a closed circuit diagram with the switch being on, as you can see in the top. Most electrical appliances do not work with batteries. They must be connected to the electrical grid through a socket. Every socket is connected by cables to a national grid, which supplies electricity created in power plants. Power plants. Power plants produce electricity from different energy sources. In thermal power plants, fossil fuels, uranium or plutonium, are used to heat up water. This produces steam. The steam moves in a turbine, which is connected to a generator. In wind power plants, wind moves a turbine which is connected to a generator. In hydroelectric power plants, water moves a turbine which is connected to a generator. And in solar power plants, heat or light from the sun are used to produce electricity. Thermal solar plants use heat from the sun to boil water and produce steam. The steam then moves a turbine. Solar panels absorb light from the sun, which is converted directly into electricity. They do not use turbines or generators.